Hi, everyone. You probably already heard us talk too much. I am Ivan, and with me is my colleague Katarina, and we're here today to talk about graph-based stream processing. So stream processing on real-time data, but with a flair of graph analytics. So running graph algorithms and graph traversals on the incoming data to find something useful about it. We have created a simple demo to demonstrate this graph stream processing. We analyzed the Twitter data set, used Apache Kafka, and yeah, it was a pretty interesting project, and we decided to share it with the community. So let's dive right in.
Okay, so first a bit about me. So I was born at the Croatian coast in a little town of Šibenik. So yeah, actually currently I'm living in a capital town of Croatia called Zagreb. I did my master's in mathematics and computer science at the Faculty of Science in Zagreb. And now I work as developer relations engineer at Memgraph. So what I actually do, we create a lot of different demo applications. We are going to show you one today. Yeah, trying to make Memgraph as easy as possible to the developers to adopt. So whenever they need some help, whenever we can create something that will show them how to use Memgraph, we do that. So a lot of different diverse activities. I love to travel, cook, and eat tasty food, I think as everyone else does. So yeah, check out my Insta. That's because I only have photos of food at my Instagram. So this is a call to follow. Thanks.
So my slide is a blatant copy of Katarina's slide, just with a few changes. I am also born and raised in Croatia. I got my master's in computer science in Zagreb. I'm currently pursuing a PhD at the same university, and I'm also a developer relations engineer. I create demo applications, tutorials, go to conferences, meetups, and I also love to travel and to cook, and I watch too much Netflix. Yeah, being truthful. So
okay, so I just requested a screen remote. Yeah, thank you. Thank you. Okay. So let me tell you a bit about the graph data model. Not sure how many of you have heard of and used graph databases before. So I'm just going to tell you a bit more about just basics about graphs. So what are actually graphs? So in Memgraph, we are working with labeled property graph model. This kind of model consists of nodes, relationships, and properties. So here on the image on the right, you can see that we have some person as a node. So this is a label of that node. We also have a city and a location node. This means that some node can have multiple labels. And we also have some kind of relationships that are connecting these nodes. So for example, a node with label person is connected with a node of labels city and location with the relationship of type lives in. So a relationship has a type. Also, you can notice that we have different kinds of properties on these nodes and relationships. So for example, person has properties name and date of birth. These are some kind of associated values, that is key value pairs that belong to either nodes or relationships. So here for a relationship, for example, relationship of type married to has a property wedding date. This is really useful when you want to filter your data, query your data with the help of some value of some properties. For example, if you are trying to find all the persons that are married to another, all person that is married to another person on specific wedding date, you are actually looking for all the relationships that have those properties. So wedding date, I don't know, in 2019, some wedding date, then you are looking for those relationships. So a graph database is something that you may have used, but probably relational database is something that you are more familiar with. So you may be asking yourselves, okay, what is the actual difference between those two? And when and why should I use graph database when I have relational database? So like the biggest difference is that in the relational databases, you have these tables and you have some kind of primary keys and foreign keys with which they are connected. But this data is not connected in the beginning. So you have to join the tables in order to connect those data. But in the graph databases, you have nodes and you have relationships that are connecting those nodes. And with each node, you already have information to which other nodes it is connected. So you have information about the relationships that are connected to it. So this is kind of different. In the beginning, your data is already connected. Another difference is that relational databases have certain schema and you have to follow this schema. This is sometimes good, but sometimes it's bad. I mean, sometimes you have some kind of data that is different for the same type of, let's say in the relational databases for the same type of table. So here, like for the same node co-location, you can have different kind of set of properties. You don't have to have same properties for every node that has label location. So that's kind of also a big difference. Another thing is when will you use graph databases and when not. So if you have too many relationships. So for example, if you have a friend that is a friend, someone who is a friend of a friend of a friend. So if you use relational databases, then you have to do a lot of joins, and these queries when you try to find something from your data become too complicated and too messy. And with graph databases, you just reverse the graph and you don't have to do joins because that data is in the beginning connected. So that's like the main differences, but we are going to talk about the specific use cases for graph databases. So the Cypher query language is also another thing that is different in graph databases. So Cypher is most widely adopted language, and at Memgraph we use Cypher, and it contains different kind of clauses like match, delete, set, return. This is very similar to like select in SQL. It also has functions, mostly like mathematical functions or something with strings, similar to that. And you can also write, this is a really good thing, you can write custom procedures. So you can actually extend this Cypher query language with different kinds of procedures written in Python, C, C++, and Rust. So whenever you cannot do something with the simple Cypher language, you can extend it and do whatever you need to get insights from your data. So this is like the main difference in language. So this is actually on the left and on the right, you're trying to achieve the same thing. You are creating some kind of simple, let's say like recommendation system. So on the left, you can notice when you write something like this in Cypher on a graph database, you are trying to find some customer that has bought some product, and you are trying to find all the other customers that also bought that product and find the products that those customers bought in order to recommend them to the first customers. So this is like some kind of simple recommendation system. And this is pretty easy in graph databases because you are just like we wrote, you are just reversing those relationships and you are trying to find the product that other person also bought. So it's actually like you are drawing it on a whiteboard. But in SQL, you have like so many lines just to do this. And this is a good example that here graph databases are really good to use because this data is a really good model for a graph model. So yeah, we're going to talk about the use cases, but this is a good example due to the large size of SQL query.
Okay, so just a few more words about why we use graph analytics. So why just not use regular stream processing and regular statistics and so on. Because there are a lot of algorithms that you may not know, but are part of this field of graph analytics. So for example, PageRank, shortest path, Dijkstra's algorithm, breadth first search, depth first search, community detection. These all fall under the purview of graphs, and data needs to be modeled as a graph in order for you to find the insights from the relationships. So some of the companies that are using graph analytics constantly are Google, which implemented the PageRank algorithm to measure the influence of web pages, Facebook uses community detection to find groups of users which have similar behaviors, maybe share the same social circle. Amazon uses collaborative filtering to do product recommendations, very similar to the query that Katarina showed before. And Pinterest and Uber Eats are good examples of how graphs can also be used to extend machine learning models to get more features for existing models, even to perform native machine learning techniques on graphs, which is picking up in the last few years. So this is a standard social network where we can, for example, do link prediction, try to find out which users could be connected to each other in the future, community detection to find which users interact more with each other and share some attributes, interests, and so on. This is a pretty cool graph. It's just a black background and all of the relationships on Facebook are visualized and glowing. You can kind of see the outline of the world. Facebook is actually one of the companies that pivoted the field of graph analytics by implementing their own custom storage engine, which was actually an inspiration for later on graph databases. Recommendation engines are a pretty popular use case for graphs, where it's easier to infer information from the relationships people have to certain products or to movies, like in this example. It's simpler to take these recommendations and do them in real time because you don't have a lot of, again, tables to join, information to infer, relationships to find, because they are already present in the data model. Supply chain management is pretty popular nowadays because of the macroeconomic situation. It's easier to find bottlenecks in the supply chain network. It's easier to find spots where some redundancy is needed, because if one node gets deleted from the graph, there could be a break in the whole chain and so on. So risk analysis and fraud detection is maybe one of the most utilized use cases for graphs. Where the performance of graph databases comes to shine. There are a lot of transactions happening each second, credit card transactions, debit card transactions, insurance claims, and so on, fields where a lot of fraud occurs. And it's important to find relationships between users who might share some similar interests and behave similarly, in this case, fraudulently. It's also easy to use community detection to find fraud rings in such networks. So
okay, next I'm going to tell you a bit about graph stream processing. So since I guess you are Apache Kafka London community, I guess you are all familiar with the stream processing. And here we are talking about graph stream processing. So what is happening? We have some kind of input data. That data is going into a stream processing engine. And once something is being calculated inside stream processing engine, we can have that stream back into we can have that data back into some output stream or do some kind of analytics on it. So Memgraph actually comes here as a stream processing engine. So if you, we are doing the different kind of graph algorithms, and you can run traditional algorithms such as PageRank, between centrality, community detection, something similar to that. But what we did there, we actually created a different kinds of dynamic graph algorithms. So whenever some kind of new data comes into Memgraph, we calculate locally around that new data, all new values, for example, of PageRank, and then we give you back the approximation. So then you can have your answers really fast, because if you think of running PageRank on, for example, tens of millions of nodes all at once, that's a pretty large data set. But in this way, you can get all the data in the correct order by doing it dynamically. So this is kind of our approach. So as I said, stream processing is a type of big data architecture where you analyze your data in real time. We are using it whenever you need to get an additional information from your data as it's being consumed. And this all happens asynchronously. So the data source and the stream processing work independently without waiting for a response from one another. So Memgraph, as I said, is that comes in the stream processing engine. So it's actually a platform for graph computation and streaming data, and it's powered by an in-memory graph database. That in-memory graph database is actually built in C++, so it's really highly performant. So it's not only a database, I mean, it's used to store graph data in memory, but it's also used to run graph analytics, especially dynamic graph algorithms. And in that way, you can analyze your streaming data really fast. Another thing that we are going to show you in our demo is actually called GQL Alchemy. This is a fully open source Python library that we are currently building. And it's an object graph mapper. And it's a link, that means that it's a link between a graph database and Python objects. So it has this OGM capabilities. It also has a query builder. So if you are not familiar with Cypher query language and you like Python, then it will be easier for you to build your queries without using Cypher. This is why we created this query builder. It also has an on-disk storage that gives you like you can store some part of your data seamlessly on disk because everything in Memgraph is in memory. But in this way, you can store some data that you are not doing your analytics on disk, so you can save some space and have more memory for doing the actual calculations. And we also offer the graph schema validation. So I said before that graph databases are schemaless, but here, if you are building some kind of application, you want to make sure that your data has a certain schema, you can do this with the help of GQL Alchemy. So
now let's get to the demo application that we created and how it actually works. This is the architecture. These are a few services, 5 of them running. So we have at the beginning the data source. We scraped Twitter for tweets. So we created a network of tweets and retweets. And we are going to analyze and find the most influential user in this network. And we are going to run community detection on this network as well to find clusters of people who are interacting more with each other, so retweeting each other more. When the data is scraped from Twitter, it's sent via Apache Kafka to our stream processing engine, in this case, Memgraph. We do these calculations. We actually run the PageRank algorithm to find the most influential node and the community detection algorithm to place the user in a community. And then we send the info to a Flask server written in Python, very simple, just so we can forward it to our front-end client in React, where we do the visualization of the network. So we wanted to actually visualize it in real time, dynamically, whenever a new tweet comes in, to place it somewhere based on its influence and based on the community it belongs to. Just one more note. The data source is actually a CSV file. We scraped Twitter for a few minutes during the holidays because of the nature of the data set that we used. And I'm going to tell you why. This is the data model. So it has a lot of users that are connected to each other with relationship retweeted. So whenever a user retweets another user, a node gets added to the network and there is a relationship between these two users. It's very simple. The only property the user node has is username. So it's a unique username which is associated with a Twitter account. And the data set is a Christmas data set. So we wanted to include all of the tweets that had the hashtag Christmas in it. And by finding the most influential user, we will find the most Christmassy person during the holidays. So that was kind of the idea. That's why we scraped Twitter during the holiday season, and that's why we added it into a CSV file. And now there's just a simple Python script creating messages every second and publishing them to a Kafka cluster. We are running the dynamic PageRank algorithm, as Katarina mentioned. So this is an incremental algorithm where we don't recalculate the PageRank value for each and every node in the network because that will be too intensive. We only do it for the newly created nodes and the ones that are affected by them. The same applies for the community detection algorithm, which is a propagation algorithm. It's also incrementally implemented and only calculates the necessary values. So for the newly added nodes and the ones that are affected by it. not all of the nodes in the network. That's how we save on computational time and on resources, of course, because when you're doing everything in real time, when you want analytics instantly, you kind of need to save time and resources wherever you can. So now let's show the demo. We created all of these services, but we orchestrated it using Docker, so it's a bit easier to start. If you never use Docker, I highly recommend it. It makes this job a lot simpler and a lot easier. So it will start all of the services at the right time. They're all on the same network.
And of course, if someone has a question, of course, you can just jump in whenever we are talking. You don't have to like wait for us to finish. we are up for the talk.
Yeah, absolutely.
Especially until Docker starts everything up.
Oh, that's the perfect time. So now all of the Kafka, Memgraph, and Python services are up and running. I'm just powering up the React client, which takes a few more seconds. And yeah, it's up. So let's reload the app. And it should start receiving messages any second now. Yeah. So what's happening at this moment is the CSV file is being streamed second by second via the Kafka cluster. Memgraph ingests the messages, calculates the PageRank value and the community where the node belongs to, and the data is visualized here in the client. So you can see the sizes of the nodes are changing because when they get a new PageRank value, the radius is directly proportionate to it. So these ones, they have a larger PageRank value than the smaller nodes. That's how we wanted to visualize the most influential node in the network. Kudos to Katarina, who used the D3.js library, also open source, to visualize the graphs. I also highly recommend it if you have any visualization needs that might look like this.
Yeah, it's really good.
So here is the community detection algorithm. As you can see, these communities are colored the same way. Every time a new node comes in, it gets assigned a community and gets the appropriate color. It's a propagation algorithm, so sometimes the colors change, the values are being recalculated and checked if everything is okay. And as you can see here, the most influential node by far is the World Music Award. And that was the Twitter account at the time that really had the largest number of followers. I can also open up Memgraph Lab. It's a visual user interface, which we use to query the data from the database. What I did now is I just retrieved all of the nodes and the relationships from the network. You can see user. It has the property cluster. So this is a property that was calculated via stream processing. It was assigned a community, and this is the PageRank value, which was also calculated in real time and assigned to the node. I can actually do something a bit more fun with a graph, just change the layout so it makes a bit more sense. I saved the design here, and when I apply it,
Yay.
yeah, now it looks a bit Twitter Christmassy. So again, the radius is proportional to the PageRank value. So this is the user World Music Award.
Yeah, and a really fun thing that you can actually do there is on the right, you can change the settings of this graph and like different, yeah, these kind of things that affect, that actually affect the graph with the D3. It's also drawn with D3. So that's like a cool thing. Yeah, when you move it, yeah.
Now they're a bit closer to each other.
Yeah.
Actually, fun fact, Katarina did a visualization on the demo here, and only afterward was our Memgraph Lab application switched also to D3. So
yeah.
kudos on being the first.
Yeah.
And that's more or less it on the demo side. Now we're gonna just talk a bit about how everything was done in the backend. So how did this stream processing happen? What we needed to run in order to get this kind of pipeline up and running.
Yep. So let me tell you a bit about that. So so how do we even translate these messages that we are receiving from Kafka? So as Ivan said, we are actually receiving messages that have some kind of information about a new retweet. So this message has I mean, it can be a retweet, it can be the message about a new tweet, but this is an example of some retweet. So we actually receive some kind of JSON, some kind of dictionary that has keys as source username and target username. So we are telling Memgraph what to do with this data. So on each new message, we are telling it to create, that is to merge. This means this merge is actually like a create, but you don't create it if you already have it in the database. So this is actually created if it's not already there. So create a new user that has a username, source username. This one is from the message that we received from Kafka, and then create another user, target username, that has a username, target username, and connect them with the retweeted relationship. So this is actually the most important part when you have Kafka Stream that you are connecting to Memgraph. You have to tell it how to translate all messages from this message, Kafka message, to Memgraph. So you are actually giving it a Cypher query that is going to be done in Memgraph once the message is there. Next, we need to set up everything with PageRank and community detection algorithm. This here is a setup of PageRank algorithm. We are actually calling PageRank online. This means this is a dynamic PageRank algorithm. And we are creating a new trigger. So we want to say whenever there is a new node, we want to set its new rank that is being calculated. So here, set node rank, and we actually want to call some new procedure. So we have a procedure that is written in Python, and this procedure is called publisher.updateRank. This means that we are sending a message to Kafka topic that the new node, that a new rank has been set. So what actually happens? So we have a message from, we have a new message that something new is there. So we need to update a rank. Once the rank is being updated, we want to send that to our front end so that we can draw everything. So we need to send this information from Memgraph to the backend, from backend to the front end. So from Memgraph, we are sending it to Kafka topic. So we actually have some kind of Kafka producer that is sending it to topic. And on the backend side, we have a Kafka consumer that is waiting for those messages and consuming them. And once it consumes new messages from that topic, it sends them to the front end via WebSocket. So once it's on the WebSocket, once we receive it on the front end, we are actually just with D3 updating everything that needs to be updated. So this here is for the rank. The same thing we do with the community detection once the cluster is being updated. So this is actually a property of that node that is being updated. This is everything written in Python with the help of GQL Alchemy. Next, what we have to do, we have to create and start the stream actually in Memgraph. And for this, we have a class in GQL Alchemy called Memgraph Kafka Stream. You can also do this everything with Cypher query, but this is like a Python way to do it. So you need to name this stream, you need to name the topics, and this transform part is actually the part that we had before. So this is a transformation module. So transform twitter.tweet is telling this stream that whenever something is there from Kafka, you need to translate it in this way. So we create a stream and then we start a stream. Next, we want to create a trigger. This trigger is whenever something new is created. So not whenever something is updated, but whenever some new node is created, we want to send this information again to the backend that we can send it to the front end. So here we are calling publisher.create. This is again another Python script that is producing messages to the Kafka topic. We are consuming it in the backend. So we are creating it with just memgraph.create trigger. So what we had to do in order to achieve this whole stream processing in Memgraph, we created a transformation module. We ran the PageRank and community detection algorithm in a similar way. We created and started a stream with GQL Alchemy, and we created a trigger and module to send those results back to Kafka topic. And this is what we had in the end. So Ivan showed you the real-time example with the demo. This is just a simple GIF. Yeah, like he already said, these nodes are proportional. Their sizes are proportional to the page rank value that they have. So the larger the node, the more important it is in the network. And on the right, whenever some node changes its community, that is that cluster property, it changes the color. So when they are the same color, they belong to the same community. And if you want to play with this Twitter data set, you can check out the Memgraph playground. I think, we can send you this all links to the chat also. So this is actually our playground when you have this couple of data sets uploaded, and you can go there and just run these query examples. You can run your own queries, play with the data sets. Yeah, Ivan is showing you now. So this is a really cool thing when you want to learn like the basics of Cypher language and also want to see what kind of data sets you can create there. I mean, what you can have in Memgraph.
If this demo doesn't seem very useful, let's say, just take into account that this same process is applied then again to the recommendation engine when you're doing product recommendations, when someone visits, for example, a web shop, in social media networks where users are constantly creating comments, posting something, where the PageRank value may provide some additional info, where the community detection algorithm can help connect other people in the platform. The demo we created was more out of fun. We had a great time playing with it, but yeah, it can also be useful.
Yeah, I also send you in the chat, I'll send you the Twitter network analytics demo. So we have this whole repository of this demo, and you can check it out. You can throw us a star. You can also check out the Memgraph GitHub, because like we are open source, you can check everything out. Throw us a star there too. I also send you the link to the Twitter sandbox. I think that I maybe didn't forget anything. But also we are hanging out at Discord. This is where our community is. So I send you the also the link to our Discord server. There is like lots of us. We like discussing different kinds of topics, whether it's Kafka related, Python related, whatever. Yeah.
Anything that has to do with graphs and stream processing in general. So that's more or less it. I hope we didn't bore you to death. Hope there are some questions. Hope you learned something new from this. Maybe if you weren't familiar with graph analytics that much, or you maybe didn't have any experience doing stream processing on incoming data, it's a pretty interesting field, and I definitely encourage everyone to learn more about it, because in today's world, a lot of companies are utilizing this kind of stream processing and real-time analytics. So it doesn't even have to be graph analytics, but yeah, Apache Kafka and stream processing is always a in-demand skill.
Yeah, I was actually really surprised by how many people are using graphs since we were at Kafka Summit, that lots of people are actually using graphs with Kafka. And I mean, they have a pretty interesting use cases. So maybe if someone, maybe you know something better, you can share with us, of course. And that's it.
This is amazing, really good. I'm quite impressed, because especially the real-time analysis is quite an achievement, right? Especially you saw the relational database and how you would kind of have to solve that. Yeah, for me, it's the first time sort of looking into like the relational DB world. I've heard of like Node4, what's that database?
Neo4j, probably.
Neo4j, sorry, yes, that's one. Yeah.
Yeah.
So Neo4j, I've heard about it, but I've never had a chance to work with it and up until now. But yeah, it's quite interesting to see what you guys done. So well done, and it seems quite useful. So have you got the code for the architecture also in the in one of the shared links, or is that something separate?
Which code did you hear?
So if I want to, for example, replicate this demo locally on my machine.
Yeah, it's open source. It's under the MIT license. It's also, I think Katarina included the link as well.
Yeah. So it's this one, Twitter Network Analytics demo in the chat that I sent, but we will send this also to the organizer so that he can send that all to you, but it's there in the chat. Do you see it?
Yeah. All right. Yeah, I do. That's fine. And do I need to have access to, like, do I need to create an account on Memgraph website in order to kind of get the data, or?
No, open source.
So you should be able to kind of just.
It's on the GitHub and it's created with a Docker Compose. So if you use it, it's actually pretty easy to just run it with Docker. Yeah.
Okay. All right, cool. Thank you for sharing. This is it's very useful for me.
No problem.
Thank you for the comments.
Yeah, and you mentioned Neo4j. So actually, lots of people ask us like, what is the main difference since lots of people are using Neo4j? I mean, it's awesome, but we are a bit different since we are more focusing on the real-time graph analytics, and we are in memory, and Neo4j is on disk. So it's a bit different in that way. And also Neo4j is implemented in Java and Memgraph is in C++. So I guess there are lots of differences that should be considered based on the use case that you may have. So yeah, it's kind of different depending on what you do.
Definitely, if you just need a graph data store, Neo4j is great. If you need real-time analytics, so running graph algorithms on streaming data, then I'd say Memgraph.
Okay. And how do you scale your architecture? So for example, if you want, obviously this is a small example. You've got,
really
so you've got, obviously you've got Kafka as your event source, and that's obviously, that will absorb the pressure from various different producers. But then on the sort of making sure that the analytics doesn't slow down because you've got so much incoming, what are the sort of strategies that Memgraph has to cover with that?
So currently scaling is mostly done via adding more memory. So if you need to have the whole graph and you need to run the analytics on the whole graph, so it's appropriate just to add more RAM to the machines. But if at some point you come up to a ceiling, there is also a limit that you can set, then the database will tell you, okay, now you either have to delete something from it, so have a sliding window, or I will just start logging all of the failed queries, so I can't add anything more to it.
So it's basically an online an in-memory solution. So you've got a real-time server that's actually going to be running. Okay. And at the moment there's no it's not distributed, so you can't distribute the load across like different multiple nodes for. And
good question. Currently we only have a read replication, so you can create multiple instances, but again, these are only to duplicate data and to achieve high availability. But the distributed version of Memgraph will be available in a few months by the end of this year. So yeah, there are a lot of use cases that have trillions, for example, of nodes and relationships, which you cannot handle on a single instance at this moment. So that's why we have to.
Yeah, that's like a big next step, I think.
Yeah. Most of our current use cases are in the hundreds of millions of nodes and edges. But yeah, for the really, really large ones, like, for example, the whole Facebook network and so on, distributed is a must-have.
Okay, excellent. And what's the sort of licensing agreement on the commercial side? Is it, do you guys support for the enterprises, or is it just for like, an open source project? How does the company?
So the actual license is a business source license. So everyone has the right to inspect the code, to propose changes on GitHub and so on. Then the license converts into Apache 2 and code is completely open source. And on the enterprise side, there are only a few features, for example, that are enterprise only. So audit logging or permissions based on roles.
Security
But even, for example, replication is included in the community edition, so open source.
Okay. All right, that's it's really cool. I'm quite interested in running this, so I might join the Discord server and just spam everybody. Like, what's the speed? How does it work?
You should. I mean, we love new good questions. It's always good to figure everything out.
You can definitely, I mean, we are called Ivan and Katarina on the Discord server, so definitely
Yeah.
ping us privately.
You'll see us there. You won't miss us.
Yeah,
All right,
we're
super.
probably the loudest ones.
Yeah. Excellent. Thanks so much, guys. Thank you.
Thank
That was all for me.
you. Yeah.
I would have a question, if you
course.
don't mind. First of all, congratulations. The presentation was really great. It was amazing.
Thanks.
The question is about how do you manage failure, right? Because what happens if something goes wrong when you are writing on a database or anything? Because based on experience, streaming applications, they don't really like exceptions popping up, right? They kind of they don't deal really nicely with it. How do you manage it?
So, for example, if you have a transaction that cannot be completed because it's in conflict with another transaction or so on, or something happened on the hardware level, you have a flag that can tell Memgraph, okay, repeat it. There is a number of retries for the transaction. So for example, next time it runs, there might be no conflict, but because another transaction finished, then it will be okay. But in the worst case, for example, when complete failure happens and Memgraph shuts down, there is a write-ahead log and snapshot files. So when it turns back up again, all the data will be saved on disk and will be loaded back up again in memory. And then when you start to stream again, you can define the offset. And this, if you don't do anything, the stream will know, of course, where to pick up again based on the consumer.
Okay, got it. Thank you.
Good question. Actually, I myself encountered it when I was doing another demo, Starlink satellite constellation simulation, and there were quite a few transactions that were in conflict with each other, and that's why I requested the feature, and the code implemented it.
It's a good thing when you work in Memgraph and you request a feature, like.
Yeah, Karina and I are probably the ones who are doing the most feature requests.
Yeah,
because we do a lot of demanding applications.
Yeah, everyone else, like, feel free to share also if you have some kind of graph database question or anything. Yeah.
One question I have is this have you had experience with triple stores, for example, as an alternative to? I'm not sure how a triple store would compare, for example, to a graph database. I noticed that you store attributes at the property. So triple stores are also called subject, property, object, or property value store.
It's like RDF, right?
RDFs, yeah.
So
I see that the attributes are stored at the edges and at the nodes. So what other, have you had experience with it? And if so, what other differences do you feel between them?
So the thing is, it mostly depends on the use case. So if you're doing some kind of semantic analysis, saving web-related information, then yeah, RDF is probably the way to go. The difference to the label property graph model is, I mean, both can be interchangeable. You can migrate an RDF to a label property graph and vice versa as well, but it will affect the performance. For example, in RDFs, what we consider relationships in the label property graph model would also be represented as a node, also subject object. And here it's sometimes a bit more convenient when you can add more information in terms of properties. So not everything is atomic, not everything is completely decoupled. Here you can have more associated information with the nodes and with the relationships, unlike in RDFs. But again, if you're doing semantic web analysis and so on, stay with RDFs.
What was the query language you were using?
Yeah, it's a Cypher query language. So yeah, you can skip to that part. So it's actually, not sure with which language can I maybe compare it with.
SQL.
Yeah, SQL, but
SQL,
yeah,
like.
it's actually, you can see like this here. If you can, yeah. So like the first thing, like N, it's in this like parentheses, like these are the they are telling you that it's a node and it's connected with this dash to a relationship. So this is different kind of parentheses, brackets, and then you have another node. So we are,
it's kind of like a pattern matching.
yeah, something.
Yeah,
Yeah,
it's
this is
exactly
actually a
pattern
pattern. Yeah,
matching.
so we are matching this kind of pattern and returning everything, these variables from it. And limit one is like, just give me this one, like Ivan just typed in. So you can have like order by something, limits by something, and here you can call your procedures. Yeah, but this is actually the simplest thing, is like to tell it's a node or it's a relationship, and there you can filter it by the name, for example, or different kind of property.
For example, if I do where,
yeah, you can do it with where or within the
username equals world music.
Yeah, this person is like sneezing a lot. a word, you written it wrong. Yeah.
Of course, I'm not a native.
Yeah. Word a. Yeah.
Thank you.
Yeah. So this is actually like he filtered the data, the node.
And in this case, what was returned?
Okay, so
comma separated NRM.
So if I remove the limit, what is returned are all of the connections to the user World Music Award. So as you can see here, we find any kind of relationship. So any node that's connected via any relationship to any node, and then we filter it and say, okay, but make this node N have the username World Music Award.
Yeah.
So the relationship and the nodes it is connected to can be anything else. So it means the rest of the graph.
But what does the return mean?
The return means we are just returning everything. We are returning the node in question, the relationship it has, and the nodes it's connected to.
You can show the data. Yeah.
So it's
got
literally rows of data. So World Music Award is connected with this relationship to the user Nicole.
So you return it like in columns.
Yeah, in columns. So this is a bit more similar to the relational database.
And can you say there, like in the return statement, like N as
yes, of course. Yeah. So let's say we are return N dot username, M dot username. Let's remove
and put it as name, like as
So
as something.
Let's say target.
Okay. Yeah. Now you change it in the column. The column name, yeah.
Got it.
So pretty similar to SQL, but yeah, the pattern matching is a bit more expressive, and there are a few features that make working with graphs easier. So the merge query, which is literally match if doesn't exist, and the ability to call procedures. So for example, to call the PageRank procedure, which will calculate the PageRank value, as we showed here. This query, for example, on Memgraph Playground, so call PageRank.get, so calculate the PageRank value for each and every node in the data set, return the username of each node and the rank of that node, and which is the order by rank. So the one with the largest rank is the first one in the sending order, and limit only to 20 results as to not have a too big workload on the browser.
Awesome.
The great questions about the query language.
Yeah, there are a lot of data sets here in Playground, so you can like try it on, like
if you want
play
to
with it.
And actually we use the same query language, so Cypher, as Neo4j. So it's pretty universal. It goes the same way. The graph
it's
data
open
model
Cypher
is the same.
standard, so we actually also implemented Cypher with some kind of extensions to that language.
This is, for example, a visualization of the European gas network. Hopefully my browser will have enough RAM, given that I'm still running the demo in the background. I should probably stop it.
That's a good idea.
I should definitely stop it. And this is the gas pipelines of Europe visualized as a graph. And then you can run graph algorithms to find bottlenecks. What's the easiest way for China to turn off the gas for the rest of Europe? We were inspired again by the macroeconomic situation, which isn't great, but we have fun playing with graphs. Yeah, that's it. Any more questions, comments?